This is screencast number 3 for Unit 5, Lesson 1. I'm on page 230, where it's asking the question, what causes seasons? Most locations on Earth experience seasons. Each season is characterized by a pattern of temperature and other weather trends. Near the equator, the temperatures are almost the same year-round, but near the poles, there are very large changes in temperature from summer to winter, or from winter to summer. We experience seasons due to the changes in the intensity of sunlight and due to the number of daylight hours as the Earth revolves around the sun. So basically, both the tilt of the axis and the fact that the Earth is spherical in shape, meaning it's a ball, plays a role in Earth's changing seasons. As Earth travels around the sun, the area of sunlight in each hemisphere changes. At an equinox, sunlight shines equally on both the northern and southern hemispheres. Half of each hemisphere is lit and half is in darkness, meaning at an equinox, half of the northern hemisphere is in daylight, half of it is in darkness. Same for the southern hemisphere. As Earth moves along in its orbit, the sunlight reaches more of one hemisphere than the other. At a solstice, the area of sunlight is at a maximum in one of the hemispheres and at a minimum in the other hemisphere. All right. Basically, equinox. Equinox means equal night. Nox is the Latin word for night, if I remember correctly. At an equinox, we're basically having the same length of day and night. At a solstice, we're either having our longest day of the year and our shortest night, or we're having our shortest day of the year and our longest night, depending on which solstice we're talking about. All right. Now you have to remember that in the northern hemisphere, when the northern hemisphere experiences summertime, that's when the southern hemisphere is experiencing wintertime. Because if the northern hemisphere, if the northern pole is tilted more towards the sun, then we are having long days, short nights, and more direct sunlight. But that means that the southern hemisphere, northern hemisphere, the southern hemisphere is doing the opposite. And I'm telling you that because I want you to keep in mind as we talk about the equinoxes and the solstices. For instance, the September equinox, it's when the Earth is in this position, sunlight shines equally on both poles. For the September equinox, for us in the northern hemisphere, that's our fall equinox. It marks the first day of fall. But in the southern hemisphere, it's going to be just the opposite. It would mark their first day of spring. The December solstice happens about 3 months after the September equinox. The December solstice for the northern hemisphere marks the first day of winter, and it's our shortest day of the year. But if it's our first day of winter, then in the southern hemisphere, it's going to be the first day of summer. Okay? A couple of months after that, about 3 months after, we have a March equinox. We're back to a day where we're having 12 hours of day and 12 hours of night. Okay? The March equinox for us in the northern hemisphere marks the first day of spring. The March equinox in the southern hemisphere, though, marks the first day of fall. The June solstice is our longest day of the year for those of us in the northern hemisphere. It's our first day of summertime. But in the southern hemisphere, it would be their first day of winter, and it would be their shortest day of the year. All of this happens basically as a result of two things. The fact that the Earth is shaped like a ball, and that sunlight is hitting more directly in some spots than it is in others. So it's due to that, and it's also due to the fact that the Earth is tilted on its axis. All right, now, why have I covered up the lovely illustration that they gave you? Well, my little viewer camera does not like trying to make sense of having some things that are white, like the typing, and then something that's black. So I actually covered that up because it tries to refocus it and it winds up just not working very well. But let's go ahead and look at the highlights and things that I made on page 230, and then we'll talk a little bit about the diagram itself. Okay, so we're answering the question, what causes seasons? Each season is characterized by a pattern of temperature and weather trends, so I highlighted and underlined that. Near the equator, the temperatures are almost the same year-round. Going down a little further, we experience seasons due to the changes in the intensity of sunlight and the number of daylight hours. We get changes in the intensity of sunlight because the Earth is spherical in shape, so sunlight hits more directly in some spots and more at an angle in other spots. And we saw that on page 228. All right. So what I did is I underlined, the thing that it all boils down to, changes in the intensity of sunlight. So that's one thing that causes the seasons. The spherical shape determines how direct the sunlight is. And the other thing is the tilt of the axis, which causes variation in the number of daylight hours we experience. Okay. I also highlighted that at an equinox, sunlight shines equally on the northern and southern hemispheres. You might make a note out to the side that an equinox means equal amount of day and night. You're going to have approximately 12 hours of sunlight and 12 hours of darkness. Okay. At a solstice, you're talking about the sunlight being at its most direct in one hemisphere and its least direct in another hemisphere. Okay. The December solstice for us in the northern hemisphere, remember, marks the first day of winter. The June solstice for us marks the first day of summer. Okay. So, as the Earth moves in its orbit around the sun over the course of the year, it will have a winter solstice. About 3 months later, it will have a spring equinox, then a summer solstice, and then a fall equinox, and then the whole cycle repeats itself. Okay. All right, I'm going to adjust it a little bit, and we're going to take a look at the diagram. Okay, I know it's very difficult for you to read any of the writing that's in the white areas, so just don't worry about that. What I want you to see is that the Earth seems to, like if you're looking down from, in space, if you're looking down on the solar system, for instance, from above our northern pole, you would see that the Earth seems to make a counterclockwise revolution around the sun. Okay? It's not that you always have to look and see the December solstice, for instance, on the right-hand side of the paper and the June solstice on the left-hand side of the paper. What you really need to pay attention to is where is the axis of rotation. Okay? Here, although it's a little hard to see, it's tipped towards the sun, which makes sense because the June solstice for us in the northern hemisphere is our first day of summer, moving along 3 months. And you notice that the terminator, that boundary between daylight and darkness, seems to kind of go from one pole to the other, so that half of the northern hemisphere is daylight, half of it's in darkness. Half of the southern hemisphere is in daylight, half of it's in darkness. Everybody's experiencing something close to a 12-hour day. That's an equinox. Okay? Going a little further in the year, about 3 months after our equinox, we have our December solstice. And if you'll notice and look carefully, it's the southern pole, the south pole, southern hemisphere, that's tipped more directly into the sun. The northern hemisphere, the axis is tipped away from the sun. So we're having winter here, and the southern hemisphere is having summer. Okay? Moving forward in time, we have another equinox. It's a little bit hard to see, especially because mine's squished into the margin. But your terminator, again, seems to go from pole to pole, dividing everything into 2 equal parts. Okay? We're going to take another look at how all of this works. I'll have a model set up for you guys to help you with this. But it's because of the Earth's axis being tilted primarily that causes the seasons. Okay. Yes, the spherical shape determines how direct the sunlight is, but if we didn't have a tilt to kind of vary which hemisphere is getting more or less direct sunlight, we would not have measurable seasons.